In this video, what we've got is we're going to answer the last question. So it's question 8. It says, sketch a graph showing the effect on chemical concentrations for questions 2 to 8. So really it should say probably 2 to 7 because 8 isn't. I mean, that is question 8. So from 2 to 7, there are some stresses put on the system. What changes would it make? So I've got a little graph here, and it started at step 2. It says, what color changes would be expected if you added vanadium 3 nitrate to the system? So what they're describing here is you're adding vanadium ions to the system. Well, if you add vanadiums, remember we've got vanadium, 2 vanadium 3s plus 2 waters plus bromine, AQ, this is liquid, AQ, and it's in equilibrium with 2 of the vanadium oxide ions and 4 acid particles and 2 bromides. So as we add vanadium 3 to it, that vanadium 3 is going to get used up and get back to equilibrium. So it's going to shift this way to use up the vanadium 3. That's also going to use up some bromines. So the bromines are also going to come down, and it's going to make 2 of the vanadium oxide ions. It's going to make 4 hydrogens. So we're going to get more hydrogens made, and we're going to get 2 bromides. So we had a sudden change in vanadiums, and everything responds. It shifts this way, these things get used up, and these things get produced. And it says, what effect would having a catalyst have on the system? Is for 3. Well, having a catalyst isn't going to do anything once it's at equilibrium. So it'll just stay flat through 3. And at 4, it says, what effect would putting the system under pressure have? Well, again, we said in the last one, there are no gases in the system. So it's just going to keep on trucking. Nothing's going to happen if you change the pressure of an aqueous solution that have no gases. Then it says, what effect would adding silver nitrate be? So we said that adding silver nitrate removes bromide ions. So the bromide ion concentration decreases, and it's going to shift this way to use them up. It decreases, so it shifts to replace them. So the bromide ions were removed, they've gone down, they need to be replaced. So as it shifts this way to replace them, we're going to get more of the vanadium oxide ions. We're going to get more of the hydrogen ions. And we're going to use up some vanadium 3s. And we're going to use up some bromines. The bromines have a lower coefficient, so the change would look a little more subtle for those. Then the next question says, what effect would adding sodium bromide have? Well, now we've added bromine to the system. So if you add, not bromine, but bromides. If we add bromide, those are going to need to get used up. It shifts this way, and my vanadium oxides are also going to get used up a bit. My hydrogen ions are going to get used up a bit. And I'm going to make my vanadium 3s. And I'm going to make some bromine. Then it says, what effect would adding hydrochloric acid have? Well, that's adding acid particles. And so if I add those up, they need to get used up a bit. So I've added this. It shifts this way. I'm going to decrease these. I'm going to decrease my bromides. I'm going to increase my vanadium 3s, and I'm going to increase my bromines. So that's how you would expect this graph to shift. You can see a sudden change here, sudden change here, sudden change here, sudden change here. Changing volume doesn't have, volume or pressure doesn't really have an effect because there are no gaseous particles. Adding a catalyst will only speed up getting to equilibrium. It doesn't change the equilibrium. The only one that we didn't mention in this was a change in temperature. And we would need to know if this was an endothermic or exothermic change to be able to address that.